All right, guys. Mr. Bennett here. Again and again and again and again and again. Mr. Bennett and our friend to the very end. Again and 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 again. With another paper again. Mr. Bennett and our friend to the end. Guys, passionate about teaching, passionate about learning. You know what I mean? So I know people might say, why am I push out so much effort? It's because of the students, you know what I mean? I've always given my all to my students. It's just that it's the first it's gonna be recorded and so forth. But I used to teach like one student fraction. A man say I struggle with fraction. So sir, can you help me after school with some fraction? Help him with fraction. And next you come tomorrow and say, sir, say you say help the man with fraction and me I struggle too. Still help him. That's how I am, you understand? We don't think about just ourselves and things. You guys are the future, and we have to do everything in our power to kind of help you guys as much as possible. All right, so guess what got now, guys? I cannot write on this paper here, Swear to God. If never write on it, I'm gonna in problem to move. When I move, the writing is going to move, and that is my problem. So guess what? I'm not going to do that. I'm going to just highlight it and we just proceed like how we normally proceed. Because what happened, it's not my, even though I bought it online. They have like a copyright on it, same way. So it's like it's not even mine. I can only read it. I wasn't expecting this. Anyway, it's all for you guys, you know what I mean? By now, everyone should have joined. So we're gonna look at one paper and the next one will come after, all right? This one I have a little explanation for some of the answers, so we can proceed. Number one, which of the following is suitable for measuring the diameter of a wire accurately? That was done earlier, and that is the micrometer, and that one is most suitable. All right, on to two. It says 10 microgram is equivalent to, this should come in your notes, guys. The answer is A. I know say grams are today 10 to the minus 6. So 10 would be times 10. 10 to the minus 6 times 10, which is equal to 10 to the 5th. Can I write on the paper? I'm so sorry about that. Nevertheless, the work must go on. The coulomb is the SI unit of, is it A, potential difference? Is it electricity? Is it current? Or is it charge? And that would be D, charge. All right, number 4. A neutral atom consists of 9 electrons, 9 protons, and 10 neutrons. The nuclear mass number is, that would be D, some form of explanation. Let me give you the form of explanation just in case you're not aware. It's the number of protons plus the number of neutrons. So it's 9 plus 10. It's the number of protons plus the number of neutrons. All right. So that gives us 19. Let's move on to 5. Ions are, is it atomic? Atoms which have gained or lost electrons, atoms of the same element which have different numbers of neutrons, atoms which are radioactive, or atoms of the same element which have different number of protons. I like off the phone. I like how it sound. I like how it sound. And that is A. Ions are formed when atoms lose or gain one or more electrons. So number 5 come from your notes. So that is E. Guys, this is the best I can do. I cannot write on the book. Physics teacher wasn't able to come through for me. I know it is. They're on holiday. This is my channel. They're not gonna make it a priority like that. You know what I mean? But at the end of the day, I have to find a way to make it work. Problem solver. All right. So let's move on to number 6. Why this the use? No one that the use. Number 6. Which of these symbols represent a nuclide of potassium containing 20 neutrons and 19 protons? And that would be C. So number 6 is C. And again, for the reasoning, number of protons plus number of neutrons. So that would be 19 plus 20 is equal to 39. All right, let's move on to 7. I want to keep the highlight as long as possible until I actually identify the answer for the next one. Number 7. Which of the following show the path taken by a beam of wire rays passing between a charged plate? So read that very carefully. And number 7 would be B, right here. Oh Lord, it's not highlight. Sorry guys, but it's B because it's a diagram, it's not highlighting. Wire rays are not deflected by charged plates. All right, so this is B right here. Let's move on to 8. An article consists of is it 2 protons and 4 neutrons, 2 protons and 2 neutrons, 1 proton and 2 neutrons, or is it 1 proton and 1 neutron? That would be P, 2 protons and 2 neutrons. And this has the same structure of the nucleus of a helium atom. All right, let's look at 9. In the sun energy is released when hydrogen nuclei combine to form a heavy nuclei. The name of this process is that would be, is it a combustion, an explosion, or is it a fission or a fusion? And that would be a fusion. During nuclear fusion, smaller nuclei combine to form larger ones. All right, so that's a little notes for you. Just in case you know what's so good for your notes. The activity of a radioactive nuclide decreases to 1/4 of its original value in 4 hours. What is the half-life of the nuclide? So that will be a half times a half is equal to quarter of its original value, taking 2 half-lives. So if 2 half-life is equal to 4, then half-life must be 2 hours. And I'm not able to write on it. So it's a half. This basically what they say. A half times a half is equal to a quarter. And its original value takes 2 half-lives. So if half-lives is equal to 4 hours, then half-life of the nuclide must be 2 hours. So that is to the C, 2 hours. All right, guys, let's move on to 11. Yeah, bro. All right, send it to me. No matter, man. All right, no problem, man. It no matter, man. It no matter. You can send it. Me sort it out. Me sort. Yeah, yeah. Actually, a PDF, a PDF, PDF, a PDF. A PDF file? Alright, good, good. Thanks. Thanks so much. Yeah, man. When I reach. Actually, I do the physics paper now. Alright, bro. Thanks. Respect. Alright. An astronaut travels from the Earth to the moon. What happens to the mass and the weight of the astronaut? Guys, that's the chemistry, you know. So me tell you my work. That was a chemistry teacher. So you know we are making progress down. If you constantly call them and bother them, you know, give them a break. So them say, alright. Mr. Benito. Like Mr. Benito, do make him do anything, alright? You understand? Yeah, man, it's all for you guys. Hit that like button, peeps. Alright. Number 11 says, an astronaut traveled from the Earth to the moon. What happens to the mass and the weight of the astronaut? Is it A, the mass decreases and the weight increases? Is it B, the mass stays constant and the weight stays constant? Or is it C, mass decreases and the weight stay constant? Or is it D, the mass stay constant and the weight decreases? Number 11 is D. And just for little notes, mass remain the same no matter where it is measured, but weight depends on the pull of gravity. Right? The pull of gravity on the moon is less than on Earth, so the weight will be less. All right, so that would be D. Let's move on to number 12. I'm feeling happy now, guys. I'm feeling happy. In an experiment, the mass and volume of 4 blocks is the same material were measured. Which of the following graph shows that result? Is it A, B, or C, or D? And this one is a bit obvious. It would be D. So it's D right here. I can't get to mark it, guys. So number 12 is D. Number 13. In an experiment, a stone was placed in a measuring cylinder containing some water. All right, let's see what they want from us. From the experiment, it is possible to calculate, is it A, the mass of the stone, B, the density of the stone, C, the weight of the stone, or D, the volume of the stone. And that would be D, the volume of the stone. The stone displaces its own volume of water in the measuring cylinder. So that's the reasoning. So that is D. I'm going to try highlight as much as possible. Number 14, a car accelerates from rest. The acceleration should decrease until the car travels at a constant velocity. Which of the following graphs shows that the velocity of the car changes over time? And that would be C. I won't be able to do it, but this is C right here. C. Acceleration is given by the gradient of the velocity on the time graph. All right. Let's move on to what's this number? 15. Which of the following statements about speed and velocity is true? Speed and velocity are exactly the same thing. No. Speed only gives the direction of motion. No. Velocity gives both the magnitude and the direction of the motion. That I know from mathematics. So it is C. Thanks for the new subscribers. Welcome, welcome. Sorry about that. I did not acknowledge you guys. So many things happening. I don't even have time to message you guys yet. But big up everyone. Welcome, welcome. All right. Newcomers, you're always welcome. All right. Let's move on to 16. The following diagram shows an extension load graph of for a spring. And they say which point mark the limit of proportionality for the spring? Is it A, B, C, or D? And that would be right here. B, I can't get to mark, but 16 is B. The limit of proportionality is where the graph ceases to be straight, to be a straight line. Example, the extension ceases directly proportional to the load. All right, so this is right here at B. Let's move on to 17. A lot of graphs and stuff, you know, guys. A lot of stuff. We have to do done. All right, 17. In which of the following graphs are the variables inversely proportional? Inversely proportional. And we know say it have to be C. As one increases, the other decreases. All right, so that's inversely proportional. And again, that is mathematics, such a beautiful, beautiful subject. All right, number 18 says, the following balance is in equilibrium, and there's a 2 and 3 m, that's 6, 9. What is the value of X? So basically, it's a clockwise movement. So we'd have 6 times 3 plus 9 times 2, and that will be equal to 36n. So x times 9 is equal to 36n. So therefore, x is equal to 4n. Again, guys, I can't get it right. I'm so sorry about that. But you guys would have the foundation from a teacher, and you guys will be able to pull through. All right? Don't worry about it. Number 19, the following balance is not equilibrium. In which position to the weight of 3n be placed so that the balance is equilibrium? Where is it, guys? So we know that it will be 6 times 1 plus 2 times 5, and that is equal to what? 16n. and it's a clockwise, so it will be 2 times 5 plus 3 equals 16 times 3 times y. So therefore, we get 3 times y is equal to 6. So y is equal to 2. So that would be B. I cannot highlight it. I'm so sorry about that. But that number 19 would be B. Remember, it's a clockwise. All right, 20. The following diagram shows 4 blocks of different weight. Which block would exert the greatest pressure on a surface when placed with its lower face downwards? Let me just make you guys get a print on all the diagrams. There you go, that's perfect. So is it A, is it B, is it C, is it D? Which number is this guy? Oh, this is number 20. All right, let me just carry out the diagram so you guys can see all of them, all 4 at once. That's perfect. Is it A, is it B, is it C, is it D? And the answer would be B, because force, pressure is equal to force divided by area, and the force would be 0.6 divided by the area, which is 1 by 1. So it is B. All right, guys. Can't get it right. I'm gonna find a way to beat this system, you know. I'm gonna set up my screenshot and screenshot it. So just give me a little time, guys. We're not joke, you know. When it comes to learning, we're not joke. 21. A partially inflated balloon was placed under a bell jar connected to a vacuum pump. And you see the diagram right there? When the vacuum pump was switched on, the volume of the balloon slowly increased. Which of the following pressure changes take place? Is it A, pressure in the balloon decreases, pressure in the bell jar increases, or is it the pressure in the balloon increases and the bell jar decreases, or is it C, the pressure in the balloon decreases and the pressure in the bell jar decreases? Or is it stay the same and the pressure in the bell jar increases? So that would be C. Remember, air is pumped out. So that is why the pressure will decrease. All right, so let's move on to 22. Which of the following diagrams correctly shows a prism dispersion of white light? Dispersion white light. There's no off there. Is it A? Is it B? Is it C? Is it D? And that would be B. And the reason for that, light rays bend towards the normal entering the prism and away from the normal leaving the prism. All right. So let's move on to 23. No time for waste. The mass of a minibus is 4 times the mass of a car. The car can travel up a hill in half the time it takes the minibus. Which of the following is true when the minibus and the car travel up the hill at a constant speed when negligible air resistance? All right. Is it A, the car and the minibus is the same, do the same work? Is it B, the car is twice as powerful as the minibus? No. the minibus and the car gain the same amount of gravitational potential energy, or the minibus is twice as powerful as the car. And we're gonna go with 23 as D. Power is equal to energy over time. Let's move on to 25. So far, so good. I'm so sorry, I can't get it right on the oh, we actually at 24 now. 24, a wire connected in a circuit carries a current of 1.2 ampere. How much charge passes a point in the circuit in 4 minutes? Is it A? Is it B? Is it C? Or is it D? What say you and why? So we know that charge is equal to the current times the time times 60, right? Well, it's basically 4 minutes, so it's to be 4 times 60, and that gives us 300. So 24 is D. (25) An immersion heater of power 100 watt is placed in a filter funnel full of crushed ice at 0 degrees and is switched on. Latent heat of fusion of ice is 340 kg. Assuming that the heat is transferred to the ice, how long will it take to convert 25 grams of ice at 0 degrees to water at 0 degrees? All right. So the energy needed would be 0.25 times 34,000, and that will give us 8,500 joule. Heat power is 100 watt per second, so that takes 8,500 divided by 100, that gives us 85 seconds. So our answer would be B. Again, guys, I'm unable to write on the paper. Please forgive me for that. It will be much easier seeing it than hearing it, but that's how it goes. We're gonna find a way to beat the system, all right? 27, a wave source operating at a frequency of 500 gigahertz emits wavelength of 0.4 meter. How long does it take for the wave to travel 8,000 meters? So that's the velocity of wave. That will be equal to 500 times 0.4. That gives us 200 minutes per second. So 8,000 divided by 200 will give us 40 seconds. Who got that one right? (28) Which of the following always true of a ray? Which of the following is always true of a ray of light reflected in a plane mirror? I is equal to sin I is equal to 1 over sin r. I and r are different planes. I plus r equal 90. Answer would be D. Angle of incidence equal to the angle of reflection. So I would equal to R. So 28 would be D. Again, let's move on to 30. The air in a syringe has volume V and pressure P. It is compressed at a constant temperature until its volume is V over 2. What is the pressure of the air after compression? And number 30 would be B2P. Pressure of the gas is inversely proportional to its volume of constant temperature. So if the volume decreases by half, the pressure must double. All right. So that's the reasoning. We're halfway there. We're halfway there. Let's go, guys. The following diagram shows plane waves front arrival at a straight barrier. Which of the following diagrams show the reflected waves? All right, so we're gonna go down so you guys can see all of it. Just bear in mind what they ask. The following diagram shows a plane wave front arriving at a straight barrier. And the question says, which of the following shows the reflected waves? Is it A, B, or C, or D? And that would be B. Again, guys, I can't write anything. So that would be B. Let's move on to 32. Join pins were attached with a candle wax to the ends of rods of 4 different materials. The opposite ends of the rods were heated in the same flame. When the candle wax melted, the drawing pin fell. From which rod was the drawing pin last to fall? Is it the aluminum? Is it the brass? Is it the glass? Or is it the iron? And that would be C. So that is the glass. A little reasoning behind this. Glass is the poorest thermal conductor, right? So the less heat is gonna come through the glass. All right, let's move on to 33. Don't conduct heat so good at all. Sounds travel PSMS in the air and Q minutes per second in glass and R minutes per second in water. Which of the following correctly shows the order of magnitude of P, Q, and R? So sounds travel P minutes per second in the air, Q minutes per second in glass, and R minutes per second in water. Which of the following correctly shows the magnitude of P, Q, and R? So is it P, Q, R, or is it Q, B? This is B. Sounds travel fastest through solids and slowest through gases. All right. That's the reason behind it. Let's move on to 34. We're going on fine so far. The following diagram shows a circuit. Now we see the circuit, right? What is the reading of the voltmeter? Is it 3 ampere, 3 voltage, or is it 4.5 voltage, 6.6 voltage, or is it 9 voltage? All right. By now, you should have worked it out. And this is C6 voltage. The sphere introduced 34. The resistor divided by the potential difference in the ratio of 2 to 1. So the reading on the voltmeter is 2 divided by 2 plus 1 times 9, and that would give you 6 volt. I'm so sorry, I'm unable to write. So it would be 2 divided by 2 plus 1 times 9, and that works out to 6. See it? This plus 1 and 9. Alright, guys. Let's go on to 35. 35 said the following diagram shows a solar panel for heating water, and I give it all of that. And what does it say now? So make that before we go down. So warm water out, pipe, cold water in, and the sunlight. Alright, so let's see what this they ask us about. Which of the following pipes would give the most efficient panel? Is it A, a copper pipe painted dull black, or is it B, a copper pipe painted shiny black, or is it C, a plastic pipe painted dull black, or is it D, a plastic pipe painted shiny black? And that would be A. Copper is a good conductor of heat, and matte black is a good absorber of radiation. Because it's black, dull black is gonna absorb, all right, heat. So 36, we're almost there. A positively charged sphere is suspended by an insulating thread inside a metal can. The outside of the can is insulated from earth. Which of the following diagrams show the resulting charges on the sphere on the can? So, is it A, B, C, or D? Can't mark on this one because it's a diagram, but number 36 is D. The sphere induces a negative charge inside the can, which leaves the outside of the can positively charged. So it's positive, the outside is positively charged. All right, let's move on to 36. A mass M is raised to height h in t seconds. The average power generated is given by, so they're asking for power. Now, power is equal to work done divided by time taken. So that further breaks down to work done is equal to force times the distance over the time. And that would give us C. All right, let's move on to 38. Guys. All right, so on to 36. Oh, what was it? 38. Two notes are played on a guitar. The notes have the same loudness, but the second note has a lower pitch. Which of the following is true of the second note when compared to the first? Is it the amplitude higher and the frequency the same, or is it the amplitude lower and the frequency the same, or is it the amplitude is the same but it has a lower frequency? And that would be C. So they have the same amplitude, but the frequency is low. Let's move on to 39. Which of the following properties is true of electromagnetic waves? Again, guys, this should come from your note. They are longitudinal waves. They have the same wavelength. They travel at the speed of light in a vacuum. Or D, they can detect by the human eye. And that is C, they travel at a speed of light in a vacuum. Let me just highlight it. Cannot mark on the paper, but I can highlight it as long as possible so you guys can make it. All right. 14. A pendulum bob was released at P and allowed to swing through Q to R. Which of the following show the position of the bob when its potential energy is maximum and when its kinetic energy is maximum? All right, let's go down now to see what's happening here. So, is it A, when P is maximum potential at P and the maximum kinetic at R? That's not right. B, Q is maximum potential and for kinetic it will be P. It will actually be C. So 40 is C. Potential energy is maximum at the highest point of swing at P, right? And it's a pendulum, the pendulum will be moving fastest. So that is the maximum kinetic energy as it reaches its lowest point at Q. All right, so that is C. And even highlight it good. Let's move on to 41. The speed of light is 3 times 10 to the 8 minutes per second. If 1 kilogram of matter is converted entirely into energy, the amount of energy released is given by, and again, this should be in your notes. Energy is equal to what? Mass times speed of the light of the vacuum. So that would be T. Let's move on to 42. The following wires are all made of the same material. Which wire has the greatest resistance? And that would be A. Longest thinner wire will have the greatest resistance. The longer and it's thinner. So A, this one here, will have the resistance. Let's move on to 43. Which of the following statements about I1, I2, and I3 is correct? So look at the diagram good because I'm going to scroll down to the options. All right, I3 is equal to I1 plus I2. No, sir. That's not right. I1 is equal to I3 and is greater than I2. No. Hold on. Yeah. 43 will be B. All right. So the lamps are connected in a parallel. So the current passing through I1 and I3 will be the same, but only a portion of that will be passed through into 2. All right. So that is the reasoning behind. All right. On to 44. Which energy transfer takes place when a torch is switched on? I'm gonna just go straight to the answer for that one. It's actually D, chemical to electrical to light. All right, guys, I'm not gonna go through all of that. Let's go straight to the answer. 45. Which of the following diagrams correctly show the path of light ray in a prismatic periscope? And again, I like this one where you don't have to do a lot of stuff. And that would be A. So this one, 45 is A. The light rays are totally internally reflected in the prism. Alright, so there you go. (46) In a metal wire, electric charge is carried by, is it electrons, ions, molecules, or proton? And that would be A, electrons. I'm just highlight this one. It can be highlighted. It's the diagram. So 46 is A. 47. An EMF is induced when a conductor moves. An EMF is induced when a conductor moves. Is it A, across magnetic field lines, B, along magnetic field lines, or is it D, around magnetic field lines, or is it D, between magnetic field lines? And that would be A. A conductor must cut magnetic field lines for a current to be induced. So 47 is A. On to 48. A ray of light is arranged so that it strikes a mirror at an angle of 30 degrees. The mirror is then rotated anti-clockwise through the angle of 30 degrees. And they show you the diagram. What is the angle of reflection after the mirror is rotated? Is it A, 15 degrees, B, 30 degrees, C, 45 degrees, or D, 60 degrees? So, what did you guys put? That is D, 60 degrees. And a little reasoning, a little food for thought. The mirror line is rotated 30 degrees anticlockwise, and the angle of incidence becomes 30 plus 60. So that's 60 degrees. So the angle of reflection is equal to 60 degrees. Let's move on to 45. Which of the following is an example of induced magnetism? A bar magnet attracts a pipe of soft iron. B, a bar magnet loses its magnetism when heated. C, similar poles of two bar magnets repel each other. Or is it D, unlike poles of two bar magnets attract each other? And that would be a bar magnet attracts a pipe of soft iron. So 49 would be A. Let's move on to 50. Just 10 to go, guys. Energy is released in the sun by, is it combustion, nuclear fusion, nuclear fission, or is it nuclear fusion, or is it radioactivity? And that would be C, nuclear fusion. So 50 is nuclear fusion. 51, a main transformer consists of 600 turns on the input coil and a total of 120 turns on the secondary coil, which can be tapped at various places. The input voltage is 240 volts. And they give you the diagram and the transformer, so look at it clearly. Before I ask the question, I'm going to go back up to it just so you guys can see what's happening. Across which pair of terminals should you connect a device which operates at 6 volts? So look again, guys. Is it P and Q, P and R, or is it Q and R, or Q and S? Let's go up and you made it, and then we come back to the options. And that would be A, P, and Q. So the formula is turns on secondary divided by 600, and we get 6 over 240, and then turns on a secondary would be 6 times 600 divided by 240, which gives us 15. So it's a connect across PQ. So that is that, and this is this. All right, let me go back up. So go back there. 52. The frame of a metal table lamp should be connected to earth. The earth protects. Is it A, cable connecting the lamp to supply, B, fuse in the plug, or is it C, lamp user, or is it D, wiring inside the lamp? And that would be C, the lamp user. 52 is C. Move on to 53. Which of the following shows the current in a primary coil and the secondary coil of a transformer? And again, this should come from your notes. That would be C. 54. When gathering data to draw a cooling curve for a beaker of hot water, it would be sensible to record the temperature every, is it 5 seconds, 30 seconds, 5 minutes, or 10 minutes? And that would be B, every 30 seconds or half a minute. 5 seconds is basically too short, guys. And 5 minutes too long. So 30 seconds should be, all right. You want to see the temperature change and so forth.